Okay, I'm gonna start class today. Hello, everyone. Today is gonna be our first kind of a review lesson where we review stuff we've learned in previous courses so we can finish out this part one of the chemistry course pretty well. So today we're gonna do a new concept called density. And we'll learn about how we use density in the lab. And then we're gonna review atomic theory and atomic mass. So we're gonna do what we've learned in like lessons 2 and 3. And we're gonna continue with those concepts. So first and foremost, I would like to introduce you to the 2020 Alphademic math competition. It's a mock AMC, and grades 8 and below can participate in this competition. And this competition is at Sunday, August 30th from 2 o'clock to 3:30 Eastern time. And it's 1 hour. You can take that test in a 1 hour block, and it's 25 questions, and it's slightly harder than an AMC 8. And it has no answer choices. It's a short answer style, similar to like what you'll see on Math Counts. And if you like math, I would highly suggest you to participate in this math competition. It's on the Alphademic website. If you look up community events, I think, and competitions, you could find and sign up for this competition. And there are prizes, I've heard from Daniel. There's prizes to this competition. So for this class, the homework last week, the class range for week 6 homework was a 4 to 6 out of 6. That's a really good score to have. And you guys have been doing well. It's a good job on your homework and keep it up. For this week, there's going to be 6 questions in a Google Forms quiz at the end. So there's going to be 6 questions. And it's of the normal spot as always, and it's already posted. And I'll post your grade and give you some written feedback on Google Classroom. And of course, if you have any questions or suggestions to improve this course, please contact me at this email below. And I'll post these slides as always. So we're getting near to the end. This is our penultimate lesson or next to last lesson for our part 1. And I'm wondering if I should continue in a part 2. So I want your guys' feedback. So I created a suggestion/improvement form on Google Classroom, and it's under the assignment tab. It's assignment under the classwork tab. And there's 7 questions, and it should take around 2 to 4 minutes of your time. And I'll appreciate it if you can fill that form as soon as possible. And thank you to everyone who has already filled out the form. There was around 5 people, I think, who have already filled out the form. So thank you if you filled out that form already. So our lesson plan, as usual, we're going to start out with density. I'll introduce density and we'll solve some different problems. Someone raised their hand. I'll unmute you, JX. What's your question? Yeah.
I don't see the form.
Oh, you don't? Okay.
Yes.
I'll do a screen share of. Okay, can you see my screen now? It should.
Yes.
Okay. So the form is under the classwork tab, and then it's right here.
Okay.
It's the one that's not like a homework. It's the chemistry, and then you click out this form.
Okay. Thank you.
Here's the form. Thank you for your question. So I'll go back to the lesson. So let me share my screen. Okay, so we're gonna first start off with density. After that, we're gonna review some atomic theory, which I covered before. It's pretty straightforward. And then the last thing we're gonna do is some atomic mass and isotopes. This lecture, you really don't need a calculator, but you could if you want. It might help in calculating the atomic mass, but everything else, and maybe density as well, you might need a calculator. So I would suggest a calculator, or you could just type in your numerical work in the chat. That's fine with me. So let's start off with density. So density is just a measurement that is mass over volume. So in equations form, it's D stands for density equals M over V, where M is the mass and V is the volume. So M equals mass and V equals volume. These problems are pretty much all pretty easy. You're going to be given two unknowns and you're going to need to solve for the third unknown. So in any density problem, you're going to have two of D, M, or V, and then you're going to have to solve for the third one. And you could do it by a simple rearranging of the equation. And the important thing about density is for a certain substance, it is always constant. So for example, the density of gold is 19.3 grams per centimeters cubed. So this thing equals D. So D equals 19.3 grams per over centimeters cubed. And for any gold, no matter how big or how small the gold pieces are, it's gonna have constant density. So the density of gold would always be 19.3 grams per centimeters cubed. It's never a different value. If it's a different value, it can't be gold. So that's what density tells us. It's one way to see if it's not the object. So if we calculated the density and we found that it was 18.6, we know that it is not gold. But if we calculate that the density is 19.3, we have evidence to support that it may be gold, but we are not certain that it has to be gold, because two objects can have the same density. So it's maybe gold. So if it matches our density, it may be gold. But if it doesn't match our density, it cannot be gold. So that's what density tells us. Okay, so here's an example problem. This is a short calculation, so please PM me in the chat when you get the answer. If an object has a mass of 15.0 grams and a volume of 10.0 centimeters cubed, find the density. And please write your answer in the form grams per centimeter cubed, which should be consistent with the units I gave. So please PM me the answer in the chat when you have the answer. And just calculate the density using this little equation right here. We have M and we have V. So I see the right answer. I really like how you guys are giving the units as well. That's a really good, important skill to have in chemistry, where you do the answer. So I'll work it through with everyone now, so you'll get a chance to see how it's gone. Okay, so we're given a mass, and we're given a volume. So we could use the D equals mV. So density is mass, which is 15.0 over 10.0. And if you do the calculations, it's just 1.50. grams per centimeter cubed. And everyone who answered that got that right, so great job. So that's just a short little calculation of density equal D equals mv. And one thing I like to mention is to keep the sig figs. Since we have 3 here and a 3 here, our answer should be 1.50 instead of 1.5, but that's one thing to keep in mind. Okay, let's move on. Oh, and see, even I messed up that one in my answer. It should be 1.50 due to the sig figs. Okay, so this problem is a piece of metal wire has a volume of 20.2 centimeters cubed and a mass of 159 grams. If we know that the metal is either manganese, which has a density of 7.21, iron, which has a density of 7.87, or nickel, which has a density of 8.90, what metal is it? So basically we're given mass and volume. We can easily use density equals mass over volume. And then we have 3 densities that we compare it to, and the one that's the closest is the identity of the substance. So this is one of the important things that density can do for you guys for a calculation. If you find the density, you can find which substance it is if you know it's a certain subset. So please type your private message me the answer when you get it. Remember, the mass is right here. And the volume is right here. So when you get out your handy calculator, you can just divide those two. I see a lot of people have the right answer, so I'll go over it. And I would encourage everyone to type in your answer in the chat, even if you get it wrong, because even I get stuff wrong in my classes too. So there's nothing bad if you get an answer wrong. So the mass is 159 grams and the volume is 20.2. And if you put it in a calculator, you get 7.87. And then you look at the densities here, 7.21, 7.87, 8.90. We know iron is the closest, so that's our answer. So it's a one step, it's pretty simple to do problem. Okay, let's do another one so you can have some more experience. It's the same problem, but it has a different volume and a different mass. It has a volume of 15.0 centimeters cubed and a mass of 134 grams. So please type in your answer in the chat when you get it done. As always, I would encourage everyone to use the chat function. And here's a hint, density equals mass over volume. So I'll give you a few more seconds. Even if I'm solving the problem, I'll still like it if you could answer in the chat. Just have more participation as that's more engaging to you guys. So that's 134 grams on the top. And on the bottom, we have 15. So the answer we have is, using my calculator, 8.93. You might be wondering, wait, none of these exact densities are 8.93. But the problem states that the metal is one of these three compounds. And the closest one to 8.93 is nickel. Since we know it must be one of these three compounds, we can often use the closest one since we can't always measure it precisely. So good job to everyone who answered it. It is nickel. Let's do another density problem. It's a little weirder this time. It's an experiment requires 43.7 grams of isopropyl alcohol. That's just a chemical. However, we don't have a mass, but we have a graduated cylinder that can measure the volume. If the bottle says that the density of isopropyl alcohol is 0.785 grams per milliliter, what is the volume of isopropyl alcohol needed in milliliters? So this might be a headache, but let me first tell you what a graduated cylinder is. This thing is a graduated cylinder. It basically just measures the volume because we don't have a balance. And using the equation D equals mass over volume. But you might be like, wait, we don't know the volume. Yeah, but this time we know the density and we know the mass, so we can solve for the volume. So we can use this same exact equation and still solve for volume. So when you have the answer, please put it in the chat. I know this one requires a calculator, so. See, some people have gotten it correct. I'll give you a few more seconds. One thing I'd like to notice is the sig figs. Since we're doing division, we keep the sig fig of the least significant. So that means 3 significant figures. So the first thing we need to do is rearrange the equation for the variables we know. Since we want to find V, let's arrange it for V. So volume is density. No, sorry. See, I could even make mistakes sometimes as well. Is mass over density. So notice I just multiplied V by the other side and divided by D. So I rearranged it for volume since that's what we want to find, the volume. And then the mass, we can just do 43.7. And the density is 0.785. And we get the final answer of 55.7 milliliters. So we'll just measure 55.7 milliliters in this graduated cylinder, and that's all. So this is a similar problem, except we solve for volume instead of density. I hope everyone understood that. And we'll do our last density problem right now. Okay, this is from the Chemistry Olympiad, so this one might be a little challenging. It might be still easy for you. So the question reads, 5 pellets of a metal have a total mass of 1.25 grams and a total volume of 0.278 milliliters. What is the density of the metal in grams per milliliter? So we have 5 pellets of metal. It has a total mass of 1.25 grams and a total volume of 0.278 milliliters. And we want to calculate the density. As always, we can always, please type in the answer into the chat when you have finished. You can just do A, B, C, or D. And of course, you'll need this equation. Density is mass over volume. So I hope this is a pretty straightforward application of this problem. But it is slightly trickier. I see people have gotten the right answers. The tricky thing is they put in this 5 pellets thing, and you're like, what? That's what got me the first time when I was reading it. I was like, do we calculate the individual pellets or do we just treat it as one whole system? But the problem said that the total mass and total volume. So we could just treat the 5 pellets as one super big pellet. So it has mass of 1.25 and a volume of 0.278. And if you do the calculations, you'll get 4.50, which is C. So the wording might have been a little tricky on this problem, but it's just this. These density problems are always you have 2 unknowns, solve for the third. And we might have to use a little algebra sometimes of rearranging the equation, but other than that, it's just that. So that's the usefulness of density. Now, we're gonna start reviewing atomic theory. So I hope this is a nice refresher for you guys. So Dalton started creating the atomic theory. So John Dalton was a British chemist, and he proposed that all matter are made up of indivisible particles called atoms. Of course, physicists have discovered subatomic particles of atoms, but in the chemistry, we consider the smallest particle the atom. Something cool about John Dalton was that he was a high school teacher since he was 12. So that was pretty cool. But that was back in the 1778. And he was a high school teacher. So I felt that was interesting. When he was like in middle school, he was teaching a high school. But I guess the education system must have been different back then. And atoms consist of 2 regions, not particles, regions. There's the nucleus, which contains the protons and neutrons, and then there's electrons. In the next slide, we'll talk about the subatomic particles. So protons, it lies in the nucleus or the center of an atom. So protons are positively charged and have a mass of 1 atomic unit. Neutrons also lie in the nucleus, and by their name, it's neutral, and they have a mass of 1 atomic unit as well. Electrons lie outside of the nucleus. It orbits the nucleus kind of, but not like a spherical orbit. It goes in a random direction orbiting the nucleus. That's because protons and electrons have opposite charges and they attract each other. Electrons have negligible mass for our considerations. It's close to 0 compared to a proton and a neutron. So now let's remember the atomic symbol. Each element has an atomic symbol, which is a 1 or 2 letter notation to represent an atom. For example, H is the atomic symbol for hydrogen. He is the atomic symbol for helium. Au is the atomic symbol of gold, and Ag is the atomic symbol of silver. So remember that if it's 2 letters, the second one is always lowercase, and regardless, the first letter is always capital. So now I'll discuss the atomic number Z. So the atomic number Z is the number of protons in the nucleus of an atom. And an element is a substance whose atoms all have the same atomic number Z. So if you have a picture like right here, all you have to do is count the number of protons. So remember, protons have positive charge. So you count how many positive particles. There's 1 here, 2 here. So you can say Z equals 2. It's that straightforward. So please type in your answer in the chat when you're done with this question. So what's the atomic number for lithium? So this is like easy. This should be pretty easy. Remember, the atomic number Z is not the sum of the neutrons and protons, it's just the number of protons. So good, everyone got it right. There's three. 1, 2, 3. Do it for one more. How about nitrogen? Let's do it relatively quickly. So what's the atomic number for nitrogen? I know it's a little tough to count all of them, but save time, I'll just do it for you. 1, 2, 3, 4, 5, 6, 7. So yeah, Z equals 7 for that case. So Z equals 7 for this case. So good job to everyone who got it right. So let's review the elements. Elements have the same number of protons in each atom. So a hydrogen element always has 1 proton. A helium element always has 2 protons. But elements may have different number of electrons, and they're called ions. And they may have a different number of neutrons, and they're called isotopes. We'll discuss isotopes later. And now the atomic mass, which is A, that's the total number of protons and neutrons in an atom, not the electrons. Do not include the electrons in your answer. So to find it, you just sum up all the protons and neutrons. In this case, there's 2 protons in this helium atom and 2 neutrons, so 2 plus 2 is 4, so a mass number 4. So let's do this problem. It's relatively easy. What's the atomic mass for lithium? So in the earlier problem, we asked the atomic, the Z, which is the atomic number. So this one, I'm asking for the atomic mass. Okay, if you forgot about what the atomic mass is, you can count the number of protons plus neutrons. So protons, there's 3. And then the neutrons, there's 1, 2, 3, 4. So 4. So you add them up and you get 7. So that's how you can do it. Do one more for nitrogen. This one might be a little tougher since it is a lot bigger, but when you have the answer, please post it and PM me in the chat. I'm sorry, the picture is kind of blurry. I do realize that. But I hope you still can see how many protons and electrons. So there's 7 protons and 7 neutrons. Sorry if you couldn't see it, but that makes the mass number 14. So that's how we do it, the mass number. So now we're going to talk about the last thing, which is review the last thing, which is the nuclide symbol. And it uses everything we've learned so far: the atomic number, the mass number, and the atomic symbol. So in a neutral atom, remember there's an equal number of protons and electrons, and every single atom we'll discuss is neutral. So this is the form that we'll see them in. So we'll see the mass number on the top, atomic number here, and in the middle, the atomic symbol. So that's how I want you to put in your answers for these questions. You could type in this, the mass number for the first line, then you can enter and do the atomic symbol for the second line, and then the last line you can do the atomic number. It's just like this. This is what one example looks like. 23 is the mass number, the atomic number is 11, and the atomic symbol is Na. So let's do that same thing for lithium. And just to help you guys out a little bit, the atomic symbol is Li. We calculated previously A equals, the mass number is the number of protons plus neutrons, which is 3 plus 4, which equals 7. And the Z, which is the atomic number, is 3. I know it can be a little confusing sometimes, giving all the mass number, atomic number. But this is the terminology you'll have to have for your introduction. Great job, guys. I see the correct answer in the chat. I basically gave you the answer. It's AZLI. So we call it 7,3 Li. So that is the correct answer. So good job to everyone who got it right. Let's do one more for this nitrogen. I realize since we've already done it before, A equals 14 and Z equals 7. So that's what we got in the previous slide. So please type your answer in the chat when you finish. And always the greater number is always on the top. So that's an easier way to remember the A from the Z. And it's alphabetical. A goes on the top and Z goes on the bottom. And the atomic symbol is N. So the correct answer is 14, 7, N. So I think that wraps up our atomic theory. And now today, for the last thing we're going to talk about how to calculate the atomic mass on the periodic table and the different isotopes. So recall, isotopes are atoms in the same element. So if it's in the same element, it has the same number of protons, but it has a different number of neutrons. So isotopes, same protons, but different neutrons. In this case, here's the 3 isotopes of hydrogen. the first one is called protium, which has 1 proton, 0 neutrons. The second one has 1 proton, which is deuterium, and 1 neutron. And the last one has 1 proton and 2 neutrons. Notice in all of these, they have the same number of protons. They all have 1 protons. And they have the same number of electrons because they're neutral. So they each have 1 electron, which are the blue spheres like, let me get the blue, like these. These are the electrons. But they differ in the number of neutrons. So protium has 0 neutrons, deuterium has 1 neutron, and tritium has 2 neutrons. So if it has a different number of neutrons, they all weigh differently. This would weigh 1 because the weight is the sum of the protons and the neutrons. This would weigh 2, and this would weigh 3. So we have to have the relative proportions to find the average weight of all hydrogen atoms. And that's what we're about to do. So the atomic mass is based on a carbon-12 scale. So 1 AMU is arbitrarily defined as 1/12 of the mass of a carbon-12 atom. So that's basically how chemists define the mass on the periodic table. They use carbon-12, since carbon is the most abundant element for life. So what we're going to be doing here is like a weighted average. So the atomic mass is the weighted average of all individual atoms. I'm sorry if the Zoom might kick us out before we finish the lecture, but if it does, then we might have to rejoin to finish out this lecture. We're almost done, but Zoom might kick us out since it has a 40-minute window. So the fractional abundance of a substance is basically the proportion that it is found in nature. So for example, if 98.9% of all neon atoms are neon 20, then the fractional abundance is 0.989. So it takes that percentage and converts it into a fraction. That's all it does. That's the decimal. So the decimal is how often in a proportion there are. How it basically tells us how big is the occurrence of neon 20. So 0.989 times of it. So this one, I'll show you an example of how to calculate this. So I will do this one with you guys, and then the last problem we have today would be an example problem about this concept. So this is calculating the atomic mass by the different isotopes. So as you can see, we have 2 different isotopes. There's one that weighs 35 and one that weighs 37. And we want to find the atomic mass given these isotopes and fractional abundances. So how to do this? We basically do the sum of the mass times the fractional abundance. It's a weighted average. So what we do is 35 times 0.76 plus 37 times 0.24. So what I did was I took the mass of it element and I multiplied it by its fractional abundance. I took the mass of this and multiplied it by its fractional abundance. So we just take all of the different isotopes and we multiply it by its fractional abundance. And then after you do the calculations, you get 35.48 AMU. And looking at a periodic table, it's 35.45, which is really close, so that's a good thing. It's off because of the significance of the number of digits in my fractional abundance. I rounded it to the hundredths place, but there's a lot more decimals, and that might slightly change the answer. So just to recap, to find the atomic mass, you just take a weighted average, which is what I just did. So our last problem for today, we're going to calculate the atomic mass of chromium. So given these fractional abundances, what is the atomic mass of chromium? You don't have to give me the number. You can just show me the work. You can show me the weighted average in the chat. That's perfectly acceptable. So when you have, so please PM me the answer when you get it. And one thing to note is that it skips 51. 51 is not an isotope of chromium. It does 50, 52, 53, and 54. So
Wait, what if
yeah,
so if you rounded it, then what if you have like say like 75.5 and then 24.5 and then you rounded it, then you would get 76 and 25, but then you would have 101%.
yeah. So sometimes if we round, we might get 101%. But in this case, I rounded it and it added up perfectly to 100%. Do you understand?
Yes, but in those rare cases, what might happen if they were like doing something important?
And if they actually do it for like the periodic table, I would say that they would keep much more digits to it, probably around 6 or 7. So it's 6 to 7 decimal places. So it's unlikely to have such an error. We won't just keep 2, we'll keep a lot more digits. Good question. So I see people have finished. You guys did a great job. So remember, it's just a weighted average. You multiply these two numbers together, and then these two numbers together, and then these two numbers together, and then these two numbers together, and you just take the sum. So doing that, you get, after doing all the tedious calculations, you get 52.06, which is really close to the periodic number of 51.99, or 52 basically. And the reason is because we only had 2 digits instead of like 6 or 7 digits in which they'll calculate the actual mass. So that's how we calculate the atomic mass. We look at the isotopes, and remember isotopes, they have a different mass because they have a different number of neutrons. But they all have the same number of protons. Remember that. Okay, our recap. Today we discussed density, which is this important equation. Density equals mass over volume. I believe we have 3 questions about density on our homework. I'll always give you 2 of these variables and you have to solve for the third. Remember, if we want to solve for like mass, for example, we can just multiply both sides by V. So mass is density times volume. So that's how we can do it. Atomic theory, I think we have 2 questions regarding about that. Basically, we need to find the atomic number, atomic mass, and the nuclide symbol. If you don't recall them, just look at these PowerPoints when I posted them later today. I know the terminology might be a little difficult sometimes to recall which is which, but after a lot of practice, you'll get used to it. And the last thing is atomic mass and isotopes, which is calculating the mass given the different isotopes. And there'll be 1 question on this on the homework for tonight, for next week. And I would highly suggest you guys all to do the homework, as it can help you learn better and digest this material better. And it's okay not to get like a high score, since it's just for a learning experience anyways. So this week there's 6 questions and it's already posted, and I'll give written feedback. And if you have any questions or suggestions to improve this course, please contact me at this email. Thank you guys, everyone, for attending, and I hope you guys are all have a safe week.